Hello friends, I am here to present my PowerPoint presentation on the topic chi-square test. First of all, Carl Parsons introduced a test to distinguish whether an observed set of frequencies differ from a specified frequency distribution. The chi-square test uses frequency data to generate a statistic. A chi-square test is a statistical test commonly used for testing independence and goodness of fit. Testing independence determines whether two or more observations across two populations are dependent on each other. Testing for goodness of fit determines if an observed frequency distribution matches a theoretical frequency distribution. Chi-square test. It is further divided into two categories: parametric and non-parametric. Under parametric, we discussed test for comparing variance, and under non-parametric, we test the independence and test for goodness of fit. Conditions for the application of chi-square test. Observations recorded and collected are on the random basis. All items in the sample must be independent. No group should contain very few items, say less than 10. Some statisticians take this number as 5, but 10 is regarded as better by most statisticians. Total number of items should be large, say at least 50. Test for comparing variance. The formula used for this is chi-square is equals to sigma square upon sigma p square into n minus 1. Chi-square test as a non-parametric test. Test of goodness of fit and test of independence. Chi-square is equals to summation of O minus E whole square upon E, where O represents observed frequencies and E represents the expected frequencies. As a test of goodness of fit, it enables us to see how well does the assumed theoretical distribution, such as binomial distribution, Poisson distribution, or normal distribution, fit to the observed data. When the calculated value of chi-square is less than the tabulated value at certain level of significance, the fit is considered to be good one, and if the calculated value is greater than the table value, the fit is not considered to be good. Example: as personal director, you want to test the perception of fairness of 3 methods of performance evaluation. Of 180 employees, 63 rated method 1 as fair, 45 rated method 2 as fair, 72 rated method 3 as fair. At the 0.05 level of significance, is there a difference in the perception? Solution: observed value are 63, 45, 72. Expected frequencies are 60, 60, 60, and observed values minus experimental frequencies gives us the following values, that is 3 minus 15, 12, and on scaling we get 9, 225, 144, and on dividing observed and the experimental frequencies by experimental frequencies we get 0.15, 3.75, 2.4, and the total comes out to be 6.3. So we set a null hypothesis that P1 is equals to P2 is equals to P3 is equals to equally probable, that is 1 by 3, and alternative hypothesis, that is H1 is set as at least 1 is different, and the level of significance is represented by alpha, which is B, which is 0.05. Here N1 is equals to 63, N2 is equals to 45, and N3 is equals to 72. Critical values. Here the chi-square comes out to be 6.3. Decision we made is we reject null hypothesis at a significance level 0.05, and the conclusion comes out to be at least one proportion is different. That is, alternate hypothesis is accepted. As a test of independence, chi-square test enables us to explain whether or not two attributes are associated. Testing independence determines whether two or more observations across two populations are dependent on each other. That is, whether one variable helps to estimate the other. If the calculated value is less than the table value at certain level of significance for a given degree of freedom, we conclude that null hypothesis stands, which means that two attributes are independent or not associated. If calculated value is greater than the tabulated value, we reject the null hypothesis. Steps involved. Determine the hypothesis. Null hypothesis is the two variables are independent. Alternative hypothesis is the two variables are associated. And the formula used in this case is E is equals to row total multiply column total divided by grand total. Calculate test statistics. Chi-square is equals to summation O minus E whole square is divided by experimental frequencies. Then we determine the degree of freedom, which is represented by df, and it is equals to r minus c multiply c minus 1. R minus 1 and c minus 1, where r denotes the number of levels in row variable and c denotes the number of levels in column variable. Compare computed test statistics against a tabulated value. The computed value of the Pearson chi-square statistics is compared with the critical value to determine if the computed value is improbable. The critical tabulated values are based on sampling distribution of the Pearson chi-square statistics. If the calculated chi-square is greater than the tabulated chi-square, then we reject null hypothesis and accept alternative hypothesis. Here we have critical values of chi-square. Example: suppose a researcher is interested in voting preferences on gun control issues. A questionnaire was developed and sent to a random sample of 90 voters. The researcher also collects information about the political party membership of the sample of 90 respondents. Bivariate frequency table or contingency table. Here the people which are in the favor of democratic country is 10 and neutral responses are 10 and opposed responses are 30 in case of a democratic category. So row total is 50 and the person who are favor in the Republican category is 15 and neutral is 50 and the people who opposes Republican category is 10 and thus the row total comes out to be 40. And the first column total is 25 and the neutral column the summation of the neutral column is also 25 and the summation of the opposed column is 40. So we as a whole we get a 90 as a grand total. Bivariate frequency table or contingency table. These highlighted entries represents the observed frequencies, and this the column which is highlighted with the orange color is represented raw frequency, and the block which represented with orange color gives us the depiction of column frequency. Determine the hypothesis. Null hypothesis is there is no difference between Democratic and Republican in their opinion or gun control issues. Alternative hypothesis: there is an association between responses to the gun control survey and the party membership in the population. Here in this case we calculated the observed frequency and the experimental frequency in each case. Then calculating test statistics. Chi-square is equals to 10 minus 13.89 whole square divided by 13.89 plus 10.13 minus 13.89 whole square divided by 13.89 plus 30 minus 22.2 whole square divided by 22.2 plus 15 minus 11.11 whole square divided by 11.11 plus 15 minus 11.11 whole square divided by 11.11 plus 10 minus 17.8 whole square divided by 17.8, which is equals to 11.03. Determine degree of freedom. On applying the formula, we get degree of freedom is equals to 2. Compare computed test statistics against tabulated value. Here the level of significance alpha is equals to 0.05, degree of freedom is 2, critical tabulated value is equals to 5.991, test statistics is 11.03, exceeds critical value, null hypothesis is rejected, and thank you.